Okay, another quick example of reference angles. So this would come after the description or the defining of reference angles in a previous video. This is just another quick example just to emphasize one more point. So where is an angle theta that's 300 degrees, right? So here's the terminal side. We know it's a positively measured angle, so we know that the terminal side rotates counterclockwise, 90, 180. Keep going down to here, that's 270, right? So 300 degrees is going to be approximately 30 degrees beyond 270, right? So that's where a 300-degree angle would be plotted. We know this is in quadrant 4, okay? 300 degrees measures the angle counterclockwise to here. So this is our angle theta. Now, as I referenced in a previous, no pun intended reference, but as I referenced in a previous video, I had to move 30 degrees beyond 270. I knew this was 90. I knew this was 180. I knew this is 270. So 30 degrees beyond that is 300, but the 30 degrees that I mentioned that goes beyond 270, that is not the reference angle. The reference angle is the angle formed by the terminal side and the closest x-axis. So that would be this angle right here, right? So the closest x-axis, excuse me, in this problem is the positive x-axis, which we would label in this instance as 360 degrees. So it's 300 degrees that goes all the way around to here, and it stops short of 360. So I did give you some quick math that you could do. You could take the absolute value of 360 and the absolute value of 300, which would both just end up being positive anyway, and you would get 60 degrees, okay? So theta prime for this 300-degree angle is 60 degrees. So this is the reference angle. Okay, now here's where people get a little confused, and that's why we're doing this example. If you're thinking to yourself, well, you told us that angles in standard position that are measured like so would be negatively measured angles. Okay, the best description that I can give you is that this is what we refer to as a coterminal angle, but not a reference angle. Okay, so I'm labeling this reference angle as 60 degrees. It's always positive. I know I mentioned that in the previous video. I'm going to mention it again. This is always positive. Okay, reference angles are always positive. We're going to talk about coterminal angles as well. Coterminal angles can be negative. Okay, reference angles cannot. So anytime you're asked to find a reference angle, okay, when you find that closest x-axis and you find the measure of that angle, just make it positive, plain and simple. Okay, so as long as you can abide by that rule, you won't get reference angles and coterminal angles screwed up once we start talking about those.